Something in the universe is collapsing very fast, and scientists are worried. Something in the universe is collapsing, and it is happening faster than anything we thought was possible. Not slowly, not over billions of years, like the quiet evolution of galaxies drifting through space, but rapidly, urgently, almost as if something has changed the rules without telling us. For a long time, we believed the universe followed a kind of cosmic rhythm. Expansion, structure, gravity, everything unfolding in a delicate balance shaped by forces we thought we understood. But now, that balance is showing cracks. Astronomers have begun to observe regions of space where entire structures appear to be compressing, collapsing inward at a rate that doesn't align with any known model. Not black holes, not normal gravitational behavior, something else. And what makes this even more unsettling is not just the collapse itself, but the speed. Because in the universe, speed tells a story. It reveals what is possible and what is not. So when something begins to move faster than the laws that define it, you are no longer just observing a phenomenon. You are standing at the edge of a question that should not exist. What could possibly be strong enough to accelerate collapse on a cosmic scale? And more importantly, why are scientists starting to worry? The disturbance. There is a place in the universe where things are not behaving the way they should. No explosion, no violent collision, no dramatic flash of light announcing its presence. Just a quiet, almost invisible distortion spreading through space. At first, it looked like a minor irregularity, a slight deviation in motion, a cluster of galaxies drifting a little too close together, something easy to dismiss. But then, the data kept coming. The movement wasn't random, it wasn't noise, it was consistent, directional, and most importantly, it was accelerating. Imagine watching a massive structure, something that should remain stable for billions of years, slowly begin to fold inward, not because of a known force pulling it, but because something deeper, something hidden, is reshaping the space around it. This is not how the universe is supposed to behave. Gravity, as we understand it, works within limits. It pulls, it binds, it shapes, but it does so predictably. It does not suddenly decide to intensify without cause, and yet that is exactly what seems to be happening. Something is increasing the rate of collapse in a region where no such increase should exist. No visible source, no clear explanation, just a growing disturbance, quietly rewriting the rules. And if this is happening in one place, the real question is not what it is, but whether it is happening somewhere else too. The signal we weren't supposed to see. It didn't begin with a discovery. It began with a discrepancy, a number that didn't align, a motion that didn't match the model, a subtle shift buried deep within streams of data collected from instruments designed to measure the universe with near-perfect precision. At first, it was easy to ignore. In astronomy, anomalies happen. Data can be noisy. Signals can be distorted by distance, interference, or the limitations of our own tools. Most irregularities disappear when observed again, but this one didn't. The same pattern kept appearing across different observations from different instruments at different times. Independent teams analyzing separate datasets began to notice the same thing. Something was pulling structures inward, and doing so with a consistency that could not be dismissed as error. This is where concern began to grow, because when a signal repeats, when it survives scrutiny, when it resists every attempt to explain it away, it stops being a mistake. It becomes a message, and this message carried a quiet but unsettling implication. The gravitational behavior in that region did not match what our equations predicted. The velocities were off. The distribution of matter seemed to be shifting faster than it should. The balance between expansion and collapse was no longer balanced. It was tipping. Astronomers began to isolate the signal, to map it, to understand its origin. But the more they refined the data, the clearer it became that this was not a local disturbance. It was embedded in the structure itself, as if space, in that region, was no longer behaving like space. And that raises a question that is far more dangerous than any anomaly. If the signal is real, and the signal is consistent, then what we are seeing is not just a collapse. It is a change in behavior at the level of the universe itself. And the deeper scientists look into it, the more they begin to realize something unsettling. This may not be something we accidentally discovered. It may be something we were never supposed to notice at all. The location. Where reality begins to break. To understand what is happening, you have to leave everything familiar behind. Past the stars you can see, past the galaxies that form the great spirals and clusters mapped across the night sky, far beyond the regions where light travels freely and structure follows the rules we recognize. This disturbance is not happening nearby. It is unfolding in one of the most remote and ancient regions of the observable universe, where distances are measured not in millions, but in billions of light years. A place where time itself feels stretched. Here, massive galaxy clusters exist as gravitational anchors, holding together vast collections of stars, gas, and dark matter. These structures are not fragile. They are among the most stable formations in the universe, shaped over billions of years by forces that rarely change suddenly. And yet, something here is changing. The region where the anomaly is occurring appears at first glance unremarkable. No extreme radiation, no visible explosion, no signature of catastrophic events, just a quiet section of the cosmic web, where galaxies should be drifting slowly, obeying the long, predictable pull of gravity. But when astronomers map the motion of these galaxies, a different picture emerges. They are not simply moving, they are converging. Not gradually, as expected, but with a subtle acceleration that becomes impossible to ignore when measured over time. The distances between them are shrinking faster than they should, as if the space separating them is no longer expanding in the same way as the rest of the universe. It is as if this region has been cut off from the cosmic rhythm. Imagine a vast ocean where every current flows outward, carrying everything gently apart. And then, in one distant corner, the water begins to pull inward instead, quietly, persistently, against the natural direction of everything else. That is what scientists are seeing, a location where the behavior of space itself seems to diverge from the universal pattern. And if space can behave differently in one region, then the question becomes unavoidable. Is this place an exception, or is it a glimpse of something much larger, something we have only just begun to detect? What should be happening? To understand why this is so unsettling, you have to step back and look at what the universe is supposed to do. For nearly a century, our understanding of the cosmos has been built on a simple, powerful observation. The universe is expanding. Galaxies are not rushing toward each other on a grand scale. They are moving apart, carried by the stretching of space itself. This expansion is not chaotic. It follows rules. It can be measured, predicted, described through equations that have held steady across decades of observation. Gravity still plays its role. It pulls matter together, forms stars, shapes galaxies, binds clusters. But on the largest scales, expansion wins. Space grows, distances increase, structures remain stable unless something extraordinary disrupts them. And that stability is key. Galaxy clusters are not fragile. They are the result of billions of years of slow accumulation, guided by gravity and balanced by the expansion of the universe. Once formed, they do not suddenly collapse without a clear and powerful cause. There are only a few known mechanisms capable of triggering such collapse. A massive black hole could distort nearby space, but its influence has limits. It cannot reach across entire clusters. Dark matter shapes structure, but it does so gradually, not with sudden acceleration. Even the most extreme cosmic events obey constraints. Everything until now has followed a kind of cosmic agreement. Expansion sets the stage, gravity shapes the actors. Time allows the story to unfold slowly. So, when astronomers observe a region where large-scale structures are not maintaining equilibrium, where distances are shrinking instead of growing, where motion accelerates without a known driver, it does not just challenge a detail, it challenges the foundation. Because if this behavior were normal, we would have seen it everywhere. It would be part of the pattern, not an exception. But it is not everywhere. It is here, in this specific region, under conditions we thought we understood. And that is what makes it dangerous. Because the universe is not supposed to behave like this, which means something is interfering with the rules. And whatever that something is, it is strong enough to override the natural expansion of space itself. What is actually happening? Now comes the moment where expectation and reality separate. When astronomers stopped asking what should be happening and focused only on what the data revealed, a pattern emerged that could not be reconciled with any known model. The structures in that region are not stable. They are contracting, not slowly, not as part of a long gravitational evolution, but with a measurable acceleration. The distances between galaxies are decreasing at a rate that suggests something is actively intensifying the collapse over time. This is not a passive process, it is dynamic. Imagine observing a system where every component begins to move inward, not because it has reached a natural endpoint, but because something is pushing the system toward it. A force, or a condition, that grows stronger as the collapse progresses. That is what the data suggests. Density is increasing faster than expected. Velocities are rising beyond predicted limits. The equilibrium between outward expansion and inward gravitational pull has been disrupted, and not gently. It has been broken. And the most unsettling part is this. There is no visible source, no central mass large enough to explain it, no explosion, no shockwave, no external interaction that could justify such behavior. The collapse is not being driven from a single point. It appears to be happening across the structure itself, as if the space within it has changed, as if the rules governing distance, motion, and gravity are no longer consistent with the rest of the universe. This is where the concern deepens, because when a system behaves differently without an identifiable cause, you are no longer dealing with a known phenomenon. You are facing something that does not fit within the framework used to describe reality. And if the framework fails here, then the next question is not whether this collapse can be explained. It is whether the laws we rely on are complete at all. The first theory, and why it fails. When something in the universe behaves in a way we do not expect, science does not panic. It searches. The first step is always the same. Look for a known cause. Find something familiar that could explain the unfamiliar behavior. And so, naturally, the first suspect was gravity in its most extreme form, a massive black hole. It would make sense. Black holes are capable of distorting space, pulling matter inward, accelerating motion beyond ordinary limits. If something large enough existed at the center of this region, it could, in theory, explain the collapse. But when astronomers mapped the area, something was missing. There was no central anchor, no single point where matter was being drawn, no extreme radiation signature, no evidence of a supermassive object exerting control over the entire structure. The collapse was not centered, it was distributed, so the focus shifted. What about dark matter? The invisible mass that holds galaxies together, shaping the large-scale structure of the universe. Perhaps an unusually dense concentration of it could be amplifying gravity beyond what we expect. But again, the data resisted the explanation. Dark matter does not behave this way. It does not suddenly increase its influence. It does not create accelerating collapse without leaving a consistent signature across surrounding regions. And more importantly, its effects are gradual. What is happening here is not gradual. It is intensifying. Each attempt to explain the phenomenon using known physics led to the same result. The numbers did not match. The models broke down. The predictions failed. And when every familiar explanation collapses under scrutiny, something uncomfortable begins to emerge. It is not that we are missing a detail. It is that we may be missing something fundamental. Because if neither black holes nor dark matter can account for what is happening, then whatever is driving this collapse is not just unknown. It is operating outside the limits of what we currently understand. The second theory, even more unsettling. When familiar explanations fail, science does something more dangerous. It begins to imagine, not recklessly, not without discipline, but with a willingness to step beyond what is already known. And in this case, the next set of possibilities is far more unsettling than anything considered before. If this collapse cannot be explained by visible matter or conventional gravity, then something unseen must be influencing the system at a deeper level. Not a massive object, not a concentration of known particles, but a change in the behavior of reality itself. Some physicists have begun to consider the possibility that this region is experiencing a variation in the fundamental properties of space, a shift in how gravity operates, a localized distortion in the fabric that defines distance and motion, not an object within space, but a change in space. There are theoretical frameworks that allow for this, models where additional dimensions exist beyond what we can perceive, fields that interact with matter in subtle, almost undetectable ways, forces that remain hidden until certain conditions are met. Under these ideas, the collapse would not be caused by something pulling from the outside. It would be driven from within, as if the rules governing that region have been altered, allowing gravity to strengthen, distances to contract, and motion to accelerate beyond expected limits. And this is where the idea becomes difficult to ignore. Because if the laws of physics can vary, even slightly, across different regions of the universe, then what we call constants may not be constant at all. They may be local. And if that is true, then the universe is not a uniform system governed by a single set of rules. It is a patchwork, a structure where reality itself can shift depending on where you are, which means this collapse may not be an isolated event. It may be the first clear sign that the universe is more flexible, more unstable, and far less predictable than we ever imagined. The hidden player. There is something we have always known, but never truly understood. A presence that does not emit light, does not interact with matter in ways we can directly observe, and yet shapes the entire structure of the universe. We call it dark matter. We call it dark energy. Names that give the illusion of understanding. But in truth, they are placeholders for something far deeper. Because most of the universe is not made of stars, planets, or galaxies. Most of it is made of something we cannot see. And now, that invisible majority is beginning to feel less like a background influence, and more like an active force. For years, dark matter has been considered the scaffolding of the cosmos, quietly holding galaxies together. Dark energy, on the other hand, has been seen as the driver of expansion, pushing everything apart on the largest scales. A balance, a tension between holding together and pulling apart. But what if that balance is not stable? What if, under certain conditions, these hidden components begin to behave differently? The region we are observing may be revealing exactly that. A place where the unseen is no longer passive. A place where whatever we call dark matter or dark energy is no longer following the role we assign to it. Instead of supporting structure, it may be compressing it. Instead of pushing outward, it may be allowing something to pull inward with greater intensity. And here is the deeper problem. We do not know what these things truly are. We do not know if dark matter is made of particles, fields, or something else entirely. We do not know why dark energy exists or why it accelerates expansion in the first place. We only know what they appear to do. And if what they appear to do begins to change, then our entire interpretation collapses with it. Because we are not just observing a strange event. We may be witnessing the moment when the hidden structure of the universe reveals that it was never fully understood. And if the invisible forces that shape everything can shift their behavior, then the question is no longer what is causing this collapse. It is what else these forces might be capable of doing. A pattern emerges. At first, it was easy to believe this was an isolated event. One region, one anomaly, one strange behavior in an otherwise predictable universe. But the deeper scientists looked, the harder it became to hold on to that idea, because similar signals began to appear. Not identical, not as pronounced, but close enough to raise a troubling possibility. Subtle deviations in motion, unexpected gravitational effects, regions where structure did not evolve exactly as it should. Individually, each could be dismissed. Small irregularities are common in a universe this vast, but when placed side by side, a pattern begins to form. And patterns are dangerous. They suggest intention, structure, repetition. Astronomers started comparing data sets across different regions of the sky, across different distances, even across different epochs of cosmic time. And what they found was not a single anomaly, but hints of a behavior that might be more widespread than anyone anticipated. It was faint, easy to overlook, but persistent, like echoes of the same phenomenon, appearing in places where they should not. This changes everything, because if the collapse is not unique, then it is not an accident. It is not a rare fluctuation or an isolated breakdown. It is part of something larger, something that may be woven into the structure of the universe itself. And this is where concern begins to replace curiosity. Because a single unexplained event can be studied, it can be contained, analyzed, eventually understood. But a pattern suggests that the rules we rely on may not apply everywhere. It suggests that what we are seeing is not an exception. It is a clue. A signal that the universe may have behaviors we have not accounted for, mechanisms we have not discovered, and limits we have not yet reached. And if this pattern continues to reveal itself, then the question is no longer whether something is collapsing. It is how many places this is already happening, without us noticing. The speed problem. There is one detail that continues to disturb scientists more than anything else. It is not the collapse itself. It is how fast it is happening. In the universe, speed is never arbitrary. Every motion, every interaction, every transformation follows limits defined by the laws of physics. Even the most extreme events unfold within boundaries that can be calculated, predicted, understood. But here, those limits are being approached, and possibly exceeded. When astronomers measured the rate at which these structures are contracting, they expected to find something gradual, a slow inward drift, consistent with gravitational influence over immense timescales. Instead, they found acceleration. Not just movement, but increasing movement. A system gaining momentum as it collapses, as if something is amplifying the process rather than resisting it. This is not normal. Gravity alone does not behave like this on such scales without a clear cause. It does not suddenly intensify across an entire region without a massive central force. It does not compress vast structures faster than the expansion of the universe can counterbalance. And yet, that is exactly what the data suggests. The collapse is not only happening, it is speeding up. And that creates a problem that cannot be ignored. Because if something can accelerate beyond expected limits, then either there is a force we have not accounted for, or the rules that define those limits are incomplete. This is where the tension reaches its peak. Because the speed of a process is not just a detail, it is a constraint. It tells us what is allowed and what is not. So when something begins to move faster than what should be allowed, you are no longer observing a rare event. You are observing a contradiction, and contradictions in physics do not stay isolated for long. They spread. They force us to question everything built around them. And in this case, the question is unavoidable. If the universe can collapse faster than it should, then what else is it capable of doing? What if our models are wrong? There is a moment in science when the problem is no longer the phenomenon. It is the framework used to understand it. For decades, our models of the universe have been refined, tested, confirmed through observation after observation. From the motion of galaxies to the expansion of space, everything seemed to fit within a structure that, while incomplete, was reliable. But reliability is not the same as truth, because a model can work until it doesn't. And when something appears that cannot be explained within that model, there are only two possibilities. Either the observation is wrong, or the model is. In this case, the observation is holding. The data has been verified, cross-checked, analyzed from multiple perspectives. The signal remains consistent. The collapse remains measurable. The speed remains impossible to ignore, which leaves only one direction to look: inward. What if the equations that describe gravity are incomplete on the largest scales? What if the interaction between matter and space is more complex than we assumed? What if there are variables, forces, or dimensions that our current models do not include? These are not small adjustments. These are foundational questions. Because if the models are wrong, even slightly, then everything built on top of them becomes uncertain. Predictions about the future of the universe, the behavior of cosmic structures, the limits of physical law, all of it depends on the assumption that the rules we have discovered are universal. But what if they are not? What if they only apply under certain conditions, in certain regions, at certain scales? Then the universe is not a single, consistent system. It is something far more complex. A reality where different regions may follow different rules, where the laws of physics are not fixed, but dependent on deeper structures we have not yet uncovered. And if that is true, then what we are witnessing is not just an anomaly. It is a warning, a signal that the foundation of our understanding may be incomplete, and that the universe still holds layers of reality we have yet to discover. The cosmic consequence. Up to this point, it has been easy to think of this as something distant, a strange event unfolding billions of light years away, isolated in a region we will never reach, affecting structures so vast that they feel disconnected from our own existence. But that distance can be deceptive, because the universe is not a collection of isolated events. It is a connected system. Every galaxy, every cluster, every filament of the cosmic web is part of a larger structure, shaped by the same underlying forces. What happens in one region is not always confined to that region. It can influence formation, evolution, and stability across unimaginable distances. And this is where the implications begin to unfold. If something is capable of accelerating collapse in one part of the universe, then it has the potential to affect how galaxies form elsewhere. It could alter the distribution of matter, disrupt the balance between expansion and gravity, and reshape the architecture of the cosmos over time. Structures we assume to be stable may not be as permanent as we believe. Clusters could evolve differently. Galaxies could form under new conditions. The large-scale map of the universe, the one we use to understand everything from cosmic history to future predictions, could slowly shift into something unfamiliar. And then there is the deeper question. What does this mean for the fate of the universe itself? For years, scientists have debated whether the universe will expand forever, slow down, or eventually collapse in a distant future. These possibilities depend on the balance of forces we think we understand. But if that balance can change, if collapse can accelerate in ways we did not predict, then those long-term predictions begin to lose their certainty. The future becomes less defined, less predictable, and that uncertainty brings something we are not used to confronting on a cosmic scale: instability. Because if the rules that govern structure and expansion are not fixed, then the universe is not moving toward a single, inevitable outcome. It is evolving in ways we may not yet be able to foresee, and what we are witnessing now may be an early sign of that shift. The most disturbing possibility: there is a line most scientists do not like to cross, not because it is forbidden, but because of where it leads. Up to this point, every explanation has tried to preserve a central idea: that the laws of physics are stable, that even if we do not fully understand them, they remain consistent across the universe. But what if that assumption is the one thing we need to question? What if the laws themselves are not fixed, not broken, not violated, but different, depending on where you are? This is the possibility that begins to emerge when all other explanations fail. Not a hidden object, not an unknown particle, not a stronger version of something we already know, but a universe where reality is not uniform, where gravity may behave slightly differently in certain regions, where the relationship between space and time may shift, where the constants we rely on are not absolute, but conditional. At first, this sounds like speculation, but there are theoretical frameworks that allow for it. Models where the fabric of the universe is influenced by deeper layers, structures that define how physical laws manifest locally. Under these ideas, what we call constants are not universal truths, but outcomes of underlying conditions. And if those conditions vary, then so do the rules. This changes everything, because it means the collapse we are observing is not just a rare event. It is a region where the rules are different, a place where the universe is not behaving incorrectly, but differently. And that is far more unsettling. Because if reality can vary from one region to another, then our understanding of the universe is not a complete map. It is a local description, a set of rules that work here, but may not apply everywhere, which means the deeper truth is still hidden. And what we are seeing now may be one of the first clear signs that the universe is more flexible, more complex, and far less stable than we ever imagined. We are still in the dark. For all the data, all the models, all the effort to understand what is happening, one truth remains unavoidable. We do not know what is causing this. The observations are real, the collapse is measurable, the acceleration is consistent. But beyond that, certainty begins to fade. Scientists continue to study the region, refining their measurements, testing new hypotheses, searching for patterns that might reveal a deeper explanation. New instruments are being used, new simulations are being built. Every possibility is being explored, and yet the answers remain out of reach. This is not unusual in science. The universe has always revealed itself slowly, one layer at a time. What we do not understand today often becomes clear tomorrow. But there is something different about this, because in most cases, even when the answer is unknown, the direction is clear. There are boundaries, expectations, a sense of where the explanation might lie. Here, that sense is missing. Every path leads to uncertainty. Every explanation introduces new questions. The deeper we look, the more the phenomenon resists being contained within what we already know. And that creates a kind of silence. Not the silence of space, but the silence of unanswered questions. A pause between discovery and understanding. It is in this silence that science is at its most honest, not claiming certainty, not forcing conclusions, simply acknowledging that the universe has revealed something real, and that we are not yet ready to explain it. Which means what we are witnessing is not just a mystery, it is an invitation an opening into a deeper layer of reality that has not yet been explored, a signal that there is still more to learn, more to uncover, more to understand. And until that understanding comes, we remain where we have always been when facing the unknown, looking outward and waiting. The final question. There is a quiet assumption we carry with us when we look at the universe, that it is stable, not unchanging but governed by rules that hold, by patterns that repeat, by laws that remain consistent no matter how far we look. It is this assumption that allows us to understand, to predict, to feel that the cosmos, vast as it is not beyond comprehension. But what if that assumption is only partially true? What if the universe is not a single unified system, but something more dynamic, more fluid, shaped by conditions we do not yet perceive? Because what we are seeing now forces a question that does not have an easy answer. If something in the universe can collapse faster than the laws that define it, then what exactly are those laws? Are they fundamental truths written into the fabric of reality itself? Or are they emergent patterns, dependent on deeper structures we have not yet discovered? And if they can vary, even slightly, even in distant regions we can barely observe, then what else have we misunderstood? Perhaps the universe is not breaking its rules. Perhaps it is revealing that the rules were never as absolute as we believed, and that realization changes the way we see everything, because it means that what we know is not the final layer of reality. It is only the beginning, a first approximation of something far more complex, far more subtle, and far more mysterious than we ever imagined. So, the next time you look up at the night sky, consider this. Not everything you see is behaving the way you think it is. Somewhere out there, beyond the reach of light and time, something is collapsing faster than it should. And in that collapse, the universe may be trying to tell us something. Not about what is happening out there, but about how little we truly understand.